Shall we wait for 1 more minute, Girish?
Yes, I think we can wait for 1 more minute and then we can start. People are still joining in. Okay, so good evening, everyone. Welcome to this session on learned bit manipulation hosted by Codechef IEMK Chapter. We have with us Shubhadeep Roy. He is presently in third year computer science department and he will be the host for today's session. So Shubhadeep, over to you.
Thank you, Girish. So yes, I will be the speaker today, and let us start presenting. We have a lot of things to discuss today. Please tell that whether you can see my screen. Is it
Yes,
visible now?
Yes, Shubhadeep, it's visible.
It's visible. Okay. So today our topic is bitwise operation, and we will deal with different types of bitwise operators. And I'll be using C++ language, but language is not a factor here because either in C, C++ or Java, the operators are more or less the same. So have you heard about these bitwise operators earlier? Anyone? Okay, so bitwise, if you have worked with some ones complement or twos complement, you know that how the thing looks like in bits. So we break down a number in binary form, and that's what every computer does. So this type of operations make the fastest. It is the fastest type of operations that we can do. So it is better than the arithmetic operations in terms of the time taken for execution. So that is why we do bitwise operations. And what are the different types of operators we'll see? That's the first task we'll see. After that, we'll solve some problems related to that. And finally, we have selected a problem from Codechef cook-off last month, and let us see whether we can reach up to that or not. So starting with the most basic bitwise operation is AND. So AND operation is just like the logical AND. We know the truth table, right? So when we have two variables A and B, and the result is A and B, we use ampersand symbol to denote bitwise AND. So suppose all the possible situations I'm considering 0, 0, 0, 1, okay. Then we have 1, 0 and 1, 1. So 0 and 0 will give us 0. Whenever we get a 0, we get 0. And when both are 1, then only we get a high output. Now, similarly, there are other operations like bitwise OR operation, which works all the same, just the difference is in place of when both are 0, then we get 0. In all other cases, whenever we get at least one high input, the output is 1. These things I think you know because it's thing of Boolean algebra in digital electronics. Similarly, the other operation that is very important is XOR. Other than AND and OR, we have XOR operator. So how that works? We write it as, okay, so the symbol for OR is this, a single vertical line, A bitwise OR B. For XOR, we use this caret symbol, A, this caret symbol, wait a second, yes, B. So how it works? Whenever two of the bits are different, then we get a high output. That means here we'll get 1, here we'll get 1. And whenever the bits are different, whenever the bits are same, we get 0. So that is how bitwise XOR works. The remaining operators that we are going to see are NOT. And NOT is an unary operator. So it does not take two variables, it just works on a single variable. Suppose we take 101, which is the binary of 5. So if we take NOT of 5, what it does, it actually reverses all the bits. So 1 becomes 0, 0 becomes 1, 1 becomes 0. That's how simple it is. And then we learn about some shifting operators. This is called right shift. It is directed towards the right hand side. That's why it's called right shift. And we have left shift operators. So as the name suggests, what does right shift do? Right shift takes each of the bit and shift it one place towards the right. Okay, you have to write how many digits I want to do right shift. For example, if I write 4 right shift 1, that means represent 4 in binary, it looks like 100. Okay, and is there any question in the chat box? Do you mean bitwise or not? Yes, I mean bitwise. So bitwise means it works bit by bit. So you can see here, first we need to write the number in binary. Once you have written the number in binary, then we have to shift depending upon the operator. So currently we're dealing with the right shift operator. So what it does, it takes everything to the right hand side. So 0 comes here towards the right hand side. Okay, this 0 will take this place and this 1 will take its place. Now the leftmost bit has become vacant, right? So what will it do? This depends upon the first bit. So here just 1, it means -4 in 2's complement form. That is very important. Many people, what they do is put a 0 here, but this should not be the correct answer. Why? Because if you put a 0 here, you are changing the sign of the number, right? We know in 2's complement form, the first bit, if it is 1, the most significant bit, if it is 1, it means the number is a negative number. Okay, and if we right shift a number, then the leftmost bit becomes vacant. So if it starts with 1, we have to put a 1. If it starts with 0, then we have to maintain the sign, we put 0. Okay, so the sign should be maintained while we are doing right shift. That is a very important thing. So if we want to do 4 right shift 1, then we need to write 0 1 0 0. So this 0 will denote that 4 is positive. Okay, otherwise just 1 0 0 will indicate that it's -4. So this is one important thing where we can make mistake. And there is no such problem for left shift. Every time whenever you do left shift, you shift all the bits towards the left hand side. Okay, so 101 will become, okay, 1 shifts on the left hand side 1. Then we have this okay, so this takes its place. Then on the right hand side, what will happen is we will get 0. So 0 will take its place. And left hand, one important thing is that what you have observed here, when we left shifted 5, this is nothing but 5. When we left shifted 5, it get doubled. Okay, so it was earlier 5 and now this is the binary for 10. And here when we right shifted 4, okay, so when we right shift 4, the right hand side 1 digit will be removed. So this 0 will, because we have only 3 places, so this 0 will be slacked off. So now we have got the value 2. So basically saying that you can multiply by 2 by just left shifting something, and you can divide something by 2 just by doing left shift operation. So left shift actually increases the place value. Basically left shift takes every bit towards the left hand side, and we have higher place values on the left hand side. Just like in any number system, in decimal number system we have tens, ones, tens, 100,000. Similarly in binary we have 2 to the power 0, 2 to the power 1, and increasing powers to the left hand side. So whenever you take something towards the left hand side, the power increases, and here the factor is 2. So we are multiplying by 2 when we are doing left shift. That's all. And to reduce something, we do right shift. So all the operators, basic operations has been covered. If you are working in Java, just last thing, if you are working in Java, you have an extra operator that is called triple this angular bracket, the 3 angular brackets towards the right hand side. It is called logical right shift. It is not present in C++. Don't try to write it in C or C++, it will give an error. So what happens for this operator is it just ignores the sign. So it just places a 0 on the left hand side. It does not maintain the sign. That's all. If you write normal right shift, it will maintain the sign. So minus will remain as minus, and after the shift, plus will remain plus, minus will remain as minus. So up to this, if you have any problem, you can tell me. Then we can go to some programs. Okay. So anyone?
Bhaiya, could you please repeat logical right shift once more?
Yes, so logical right shift, the difference between, okay, example. So suppose -4, okay, let me go to a new page. -4 in 2's complement, we can write it in this way. Let us take 4 bits, then it's easier to understand. So you can take any number of bits. If it is minus, then you can fill infinite number of ones on the left hand side, right? That is the rule of 2's complement representation. So suppose I'm taking only 3 bits, then -4 is represented in this way. So if I first apply -4, right shift 1, okay, then what will happen is that it will be converted to -2 because right shift divides something by 2. Okay, it is value will decrease. So now it will become just 1 0. Okay, and this side will be 1. This is the difference between right shift and that triple shift. Okay, so when you do this thing, the outcome is this. Okay, now what is the difference when we use this thing? Let me use the different color. So when we do -4 and we apply this logical right shift and then we write 1, what happens is this bit will be 0, so it ignores the sign. Okay, so your -4 will become 2, it will not be -2. So that's all. If you want to remain, if you want to maintain the sign, you want to keep negative, then you do normal right shift, but this is only available in Java. You will not get this in C++. Okay, that's the difference. And any other problem? So let us go to the program. See, there are in numbers there are so many programs, but they are very easy. So starting with the first one is just the application of whatever we have discussed right now. So see, what I have done is these are just including all the libraries that we might need, and this is the main function. Okay, these are all parts of the syntax. The main thing comes from here. I have taken two numbers in I and j. Suppose this is a negative number -6 and this is positive number +4. Now I have done all the operators. I have used all the operators that I've discussed right now. So first of all is logical AND. So I and j. Second one, similarly, all the ones you can see. This is OR. This is bitwise OR. This is the NOT. It is an unary operator. So there is only one operand. And then we have done right shift and left shift. And so let us run and see what are the outputs. Wait a second. Yes. So yes, -6 and 4 gives you 0. You can try it out. Let me do one thing. First, I will do this thing for you, and all the rest, it's the homework. You can try it yourself. So -6 and 4. So -6, how we write -6? So suppose I write 6. Okay, this is the magnitude in binary. So to make -6, I need to take its 2's complement. So what is the 2's complement? Just reverse the bits. It will become 1 complement, 1's complement, and I add 1 to it. Okay, so first of all, let me take 4 bits because +6, okay, right? That is the magnitude. To make it -6, I need to reverse all the bits. This is the 1's complement form. Okay, this is the 1's complement form. And by adding 1, I get the 2's complement form, which is -6. So it will look like 1 0 1 0. Okay, this is -6 in 2's complement form. And what I've written plus and 4, right? So what is 4? So 1 0 1 0 and 4. So in 4 bits, +4 will look like this. So now if I apply AND, logical AND, what happens? 0 and 0, we have discussed in the truth table. 2 zeros will give us 0 because it is AND operation. So similarly, if anytime we get 0, we get the result is 0. Only 1 and 1 gives us 1. So there is no such case. So the result is 0. So it's justified, right? It is justified. Now, since we have taken integer variables, note it very carefully. We have taken integer variables. So the results are also shown as integers. Okay, we'll get 0 when we do right shift or left shift. We can see that the value will be multiplied. So -6 becomes -12. Why? Because I left shifted by 1. If I left shift by 2, it will become -6 into 2 into 2. So 2 to the power 2. So if, you can raise something to any number of 2's power. Okay, so if you want to multiply 2 to the power 3, you just do left shift by 3. And here is a common mistake. I've shown it intentionally. If you forget to give the bracket, okay, if you forget to give the bracket, then this is not treated as left shift, okay, because it has also another meaning which is of higher precedence. When we use C in and C out, those who work in C++, they might know that these are some standard functions which we use to take input and output. So this is used for directing something to the output stream. Okay, so don't forget to give the parenthesis, otherwise it is what it is doing, it is printing I, which is -6, and after that it is printing 1. Okay, so don't think that this is left shift. This is not treated as left shift, so please give the brackets. So I don't think there are any other chance of making mistakes here. So that was just an introductory use of all the different types of operators that we have seen. Any problem in this program? Anyone? It's just how we have, this is the main part. All these things are just fancy things just for printing. Okay, this is the actual part. Now going to the next program, the same thing we have done, but since it is bitwise calculation, it is easier to visualize, right? If we don't take it as integers but display it as 1010, right? So this is a keyword which we use bit set, and we can mention the number of bits we want. So I have taken 5 bits representation. So if I run it, you will see that the answers are shown in the form of zeros and ones, okay, not like integers. So let me see where it is. Wait a second. Yes, so -6 and 4 gives you 0, but it is represented as a stream of bits, right? 0 0 0 in 5 bits, because I have taken the mentioned the size 5. The default is 32, the length is 32, but I not want so long representation. Okay, so you can check it out, and this is quite easier. So it is always recommended that whenever you're working with bits, try to display it in the terms of zeros and ones. Also, there is an alternative way to represent it. I think some of you know how to write it. Like 0b is the code for binary. Okay, if I write 0b100, it is taken as 4. Okay, if I write 0b101, it is taken as 5. But if I just write 101, it is taken as 101 in decimal number system. So this 0b prefix makes it a binary literal, like we have 0 for octal and 0x for hexadecimal. So these are some of the tricks you can apply. Next program. So up to these first 2 programs, there is any doubt how we are doing these things, how we are getting these results? No, right? It's good because the speed is nice. We can complete all the programs today. So the third program is an application, not a direct application, but an indirect one. So if the questionnaire says you, I'm giving you a number, and you have to tell whether it's odd or even. So we are used to doing it in a normal way, like if n mod 2 is 0, that means it is an even number, and if the modulation operation it gives us 1, then it is an odd number. Okay, but there is a faster way, which is if you do this thing n and 1 and the result is 1, then it is an odd number. Now what is the reason behind it? Does anyone know? Then you can unmute and say, or else I will discuss it.
The first place where the 1 is there, if it is 1,
First place from left or right?
the rightmost part.
This one, right?
Yeah, this one.
First place
If
from
this
the
is
right.
1,
Okay, if
yeah,
this is 1,
if this is 1, and if we do and with the same 1, we get 1. That means
yes,
if it is odd, then only it will contain 1. If it is
right,
even, then it will contain 0.
right. So suppose we take an example, as he said, say 5 is an odd number, right? So if you take 5, it is represented as 101. So what are we doing? We are doing and with 1. Okay, I should not write and here. I should represent both in 3 bits. Suppose 101 and 001. Okay. Now if I take and, what happens? If this is an odd number, it has to end in 1. Why? Because see, in 2's power, you can represent 5 as 4 plus 1. So when you represent this is 2 to the power 0, this is 2 to the power 2. Okay, so these are the place values. So you will get this thing at the end of every odd number when you try to express it in terms of expansion. So that's why we will get the rightmost bit as 1. And whenever you do this AND operation, you have to get this as 1. Whatever happens on the left hand side, we don't care. Okay, because these are all zeros. Okay, this will be cancelled out. 0, all will be 0, 0, 0. The rightmost bit will be 1. So if it is not 1, then it is even. If it is 1, then it is odd. So easy to calculate. So next time, never use that mod 2 is equal to 0. From the next time, you can do just this thing, and you will get that it is odd or even. So next thing, going to a new type of application. Up to this point of time, how many of you use bitwise to swap something? I don't think many of you use this. We generally take the third variable temp, and we know what we do. And then so there is another way where we can avoid the third variable, but this is the fastest way. What I have done here, this is just a function which swaps 2 numbers, and this is just not passed by value. So we have taken the ampersand operation so that we can ensure that the values are not only changed, but the original variables are also changed. Okay, we are taking the reference, and just by these 3 lines, if you just write these 3 lines, x will take the value of y and y will take the value of x. So it is not very intuitive to just figure out verbally. It's better to take an example. So any two numbers you can write in the chat box and I'll show how this swapping is happening. Please write in the chat box any two numbers which you want to swap. Or can someone tell, because okay, I can see the chat box. 100 and 200. Wow, 100. If I express 100, it will be so long, right? Okay, 5 and 8 is quite handsome. 5 and 8. So 5 and 8, it will be quick. Let me go to a fresh page. 5 and 8. Suppose x is 5, okay, and y is 8. It is taking time to display, just right. Y is 8, okay. So what is 5? 5 is 1, 0, 1. And 8 is 1, 0, 0. So let me bring everything to this. Wait a second. So 5-bit representation, right? 5-bit representation. Now first step is x is XOR y. This was the first step, I think. X XOR y. This is the first step. So when we do XOR, what we get? Different 1, same 0. Okay. Let me write vertically. Okay. Otherwise it will create problem. So 0, 0, 1, 0, 1, and we have 0. Let me quicken up this speed. It's taking so slow. Yes. Now quickly. 0, 1, 1, 0, 0. Same means 0. Different is 1. Different is 1. Same is 0. Okay. What is this? This is just, you consider it as a number. So first of all, you store this thing in x. X becomes 0, 1, 1, 0, 1. Okay. What is the next step? Y is XOR y. If I'm not wrong, this is the next step. So the right hand side always remains same. It is easy to remember. XOR y, XOR y. Also in the third step, you'll see XOR y. So now x is this thing, and what is y? Y has not changed. Y is same. 0, 1, 0, 0, 0. Okay. Now you do XOR y again. So what you get? Different is 1, same is 0. Different is 1, same is 0. Same is 0. Okay. So now y is this thing. So you can see this is 5. This is nothing but 5. So y has already taken the value 5. Okay. So y gets the value 5. X is yet not fixed. Wait for x. The last step is x is the same thing. Okay. I'm not writing it. X is the same thing. So what is the latest value of x? This is the latest value of x. So let me write it here with a different color. X is 0, 1, 1, 0, 1. And what is y? Y is this thing. 0, 0, 1, 0, 1. Now if I take XOR, same is 0, same is 0, same is 0, different is 1, and same is 0. So now you can see this is nothing but the binary form of 8. So now x has become 8 and y has become 5. After just these 3 steps, you have swapped the values. So this is how this process works. Next time, use this thing. Just keep a function in your template, and whenever you're asked to swap, use this thing. It's very quick. Fine with this, we can go to the next program. Okay, so it's 23 minutes. We have much time left. This is a very interesting application. You can toggle a given string. Suppose what is your name? Suppose your name is Akash. So you're writing A capital and all the remaining letters small. If I pass it through this function, it will make A small and all the other letters capital. So it is just toggling the characters present in a string. And how can we change something from lowercase to uppercase using bitwise operations? That is interesting part. So don't look at the main function. It's just nothing interesting here. The actual thing happens within this function. What are we doing is we are taking every character. Okay, every character we are taking, and we are doing XOR with 32. And why are we doing XOR with 32? So I have a picture that I've taken for ASCII values. So that will be very helpful, because you see that the small a and the capital A, do you know in ASCII, small a and capital A, they differ by 32. So if we do XOR, let me show you what happens, you'll understand. So just give me some few seconds. So I have IEMK. Yes. Tell me whether you can see my screen properly. Yes. So now can you see why I am doing XOR with 32? Because 32 means this place value. You can see that small a and capital A differs only in this place, right? All other things are exactly same in capital A and small a. Same for capital B and small b. Everything is same except this 32 place value. Okay, the 6th bit from the right hand side. That is because the difference in ASCII value, you can see 66 and 98, the difference is 32. So any comments in the chat box? So what is, okay, I don't understand. So you can speak out if you want to, if you have any doubt, right? Why are you doing XOR with 32? Because the moment we do XOR, since everything is same, right? Everything is same in capital C and small c, everything will become 0, 0, 0, 0, 0, but only this bit will be 1. Okay, only this bit will be 1. So if you want to toggle something, you just make you just change from 1 to 0, that XOR does, right? If I take XOR of this and this, what will happen? You just take a pen and a copy and do XOR of this thing and this thing. If you take C, it will become capital C. If you take capital C, it will become small c. Just XOR it with 1 and 5 zeros after that. That is 32. Okay, that is the trick which we play here to convert either smaller case to capital case or capital case to smaller case. Okay, that is done for each and every character of this string. And we will run this to see what happens. Suppose original string is cherry, I can change it. Let me make it something like a kite. Okay, KIT capital E. Now this will be toggled. Okay, when I run it, it will be toggled. So it takes some time. Yes, so original string is, I think you can see this, original string is kite, and the chain string, the toggle string is K becomes small, IT becomes capital, E becomes small. Okay. So it's no need to write down this program. We will provide everything to you. You are connected on Discord. We will provide it there. Just see how it is working. If there is any doubt, you can ask me that how this is possible. What is happening here? If there is any doubt. Anyone?
What will be the time complexity?
Okay, so time complexity, what do you think? We are traversing throughout the string. It depends upon the length of the string, because this is O1 operation. Okay, let me write it here. When you are doing bitwise with something, it is always constant time, but that we are doing n number of times. Okay, so it is O1 into n, which is where n is the length of the string. Clear? Okay, because this loop runs for throughout the string, right? This loop runs throughout the string. Okay, somebody might have confusion in understanding this. I have written string, the character of the string is not equal to null. So if you have learned C, you know that not in C, in C++, there's concept of strings that even in C we have character arrays. It terminates with a null character. String in C++ terminates with a null character. So the condition that I've kept here, as long as it is not null, that means string is still valid. If you reach null, that string has come to an end. So this is just a loop to run throughout the string. So I think you know what is the time complexity. It's linear. So it is clear, right? Now, the time complexity, I hope it is. So now go to the next problem. In the next problem, we have tried to find out whether a number is a power of 2. So take any example like 64, 128, okay, 1024, all these things are perfect powers of 2. So how to check something is a power of 2? So this is not, let me show it on pen and paper. Just let me discuss how this is working, how this thing is giving you that whether the number is power of 2 or not. So let us take any value of x. Can you suggest any values of x in the chat box? I'll take that example. Any values? Where is the chat box? Or anyone can speak out for any values of x? Yes, 41. You're interested in such dangerous values. Okay, any small values, 41 will take a very long time. Okay, want to save time, right? The smaller values, 14, 11. Okay, 11, no problem. 11. So 11. So what is 11? 1011, right? This is 11. And what have we written? Let us just execute that and we'll see that we are getting the answer. So what have we written? We have written x and x minus 1. So we are taking logical and, not logical and, bitwise and. Okay, don't confuse, it's very confusing. Logical just takes 2 ampersand symbol, this is logical and bitwise only takes a single and. Okay, this is bitwise, this is logical. So now we are doing x and x minus 1. X and x minus 1. So what is the previous number? The previous number is 10. What is 10? 10 is 101, 1010. This is 10 and this is 11. Let me write it. This is 11 and this is 10. If you take and, what happens? So I'll erase this. Wait a second. Where is the eraser? No problem. Just a second. Okay, let it remain, let it remain. So we have 1 0 1 1, I am writing here, and 1 0 1 0. So if I take AND, then I get only this bit is 1 and this bit is 1, other things are 0. So AND with the previous value. And what was our aim? Our aim was to check whether it's a perfect power of 2. So for perfect powers of 2, like we have 4, we have 6, we have 4, we have 8, what is the property? The property is only the first thing is 1 and everything before is 0. And anything which is n minus 1, like 3 0 1 1, it is just the perfect complement. It is just the perfect complement, right? See, this is 4, this is 3, this is the perfect power of 2, and just the previous number is the exactly opposite. So whenever we take AND with something which is perfect complement, like it is like true and false, it is like 1 and 0. So 4 and 3 is something which is perfectly complement. So whenever we take AND, it results to 0, a big 0. Since this result is not 0, it confirms that 11 is not a perfect power of 2. Okay, 11 is not a power of 2. 16 is a power of 2. So if we have taken 16, we would have got something like this, 1 and 4 zeros, this is 16, and the previous number would be 15. And now if you take ampersand, that means AND operation, then everything will cancel out, 0 0 0, and the result is 0. So to check something is a power of 2, the best way, the easiest way is to take AND with the previous number. If you get 0, it means that it was a power of 2, and if it does not give you 0, it means that it was not a power of 2. Okay, okay, same thing. If you take about 10, you take 10 and 9, you will not get 0. Okay, so that proves that 10 is not a power of 2. Fine. So this is done with the 6th problem. Now we go to the 7th problem. Okay, let me shift this here. 7th problem. Yes, 7th problem, it checks something as the number of set bits. So let me tell you this is nothing different. Set bits. What is set bits? The one values are called set bits. Like true, we call it true, we call it set, we call it on off. All these are same thing. On off, set, not set, true, false, 1 0, everything is same. So set bits is it will give you the number of ones a number has. So let us take an example. Suppose I ask you how many ones are there in 11. You will tell me 3 ones are there. So if I pass 11 to this function, my return will be an integer which is 3. So let me check first of all whether it is working properly or not. Let me make it 11. And if I run this program, I'll get 3. Wait a second. Yes. So it says that 11 has 3 set bits, which is correct. 11 has 3 set bits. Now, how are we calculating this? How are we calculating this? Every step we are doing this operation, and it is a special operation. Will I give you some time to figure it out? How is this happening? Because I have told you the trick. I've already shown you the formula, but can anyone interpret this formula? How this is counting? Because the next step is count plus plus. So you can know that I am counting every such event. And what is this event? What it is doing? So that I'm counting it. Can anyone say? Okay. Just you can try, just try, or I just shall give you just 10 seconds. Anyone? Or let me tell you this. Okay. So I am doing ampersand of n with the previous number. What does it do? It is naturally not very intuitive, so you cannot figure it out verbally. You have to take out, just take any example. Suppose I want to find the number of set bits in 11. That was our question, right? 1 0 1 1. Okay. Now the previous number, which is n minus 1, that is 10. 1 0 1 0. Now n becomes n and n minus 1. Just do it blindly, what it tells, and you will see what happens. Gradually, after 2-3 examples, you'll get the intuition. Okay. So let me write the result here. Okay, I'm writing the result on top. I'm not any space under it. So and 1 0 will give you 0, 1 1 will give you 1, 0 0 will give you 0, and 1 1 will give you 1. So this was our original number. This was our n. Okay. Now what do you observe? This 1 has been removed. Okay, after one operation, after doing this operation for one time, I have removed the 1 from the right hand side. I have removed the rightmost 1. If you repeat this thing, okay, now the new value of n is not 1011. The new value of n is 1010. If I repeat this operation, that means I do 1010 and I do AND with the previous number, which is 9. That means 1001. Okay, if I do this operation, I get 0001. So now you can see that this one was also removed. Okay, you will not find this one. So what is this line doing? This line is very special. It is removing the ones from the right hand side. Okay, so if you run it, suppose 3 times, all the 3 ones will be removed. If I run it one more time, what will happen? I will do 8 and 7, and you know that 8 is a perfect power of 2. And if I do AND with the previous number 7, it is perfectly complementary. So AND will give me 0. Okay, so all the ones were removed. And how many times did we take to remove the ones? Naturally, it is the number of ones present. So we took 3 times, 3 iterations, all the 3 ones were removed, right? So the time complexity is big O of number of ones, number of set bits. You can try it in other ways, like you can go from the right bit and check whether it's 1 or not, but that will take a linear time. But this is even shorter. Can we do n is equals to n minus 1 instead? Okay, so he says that can we do n is equals to n minus 1 instead? Then then you have to change the code here, because you cannot count this step. Otherwise, suppose I give you 10 and n is equals to n minus 1 will take 10 times for the loop to end. So naturally the answer is not 10, answer is 3. So you have to change the code accordingly. It's not that there is only one possible answer, there are multiple possible ways. So if you just change it to the previous number, then you have to count how many ones are there. So you can just compare that by any operation that comes to your mind. You can try and test it with values. So this is the simplest way, right? Just 2 lines, and you can get the number of set bits. Set bit means nothing but the ones present. So let me try it with another value. Suppose instead of 11, I can try it with 15. And if I run it, okay, 15 has 4 ones, right? So I should get 4, not 3 this time. So 4, please. Yes. So 4, we have got 4. So it is working properly. So many applications we have seen, even on odd, swapping numbers, set bits, okay, power of 2. And now the 8th program, before which then we'll discuss a Codechef problem, which came in this book of, I think we have time, right? 37 minutes. Okay, we have time. So this is a very interesting problem. Before I show you the solution, I want to hear from you. I'm telling you the problem verbally, please listen to it. There are n number of elements in an array given to you, okay? It is said that in this array, only one element is unique and everything else is repeating. It can repeat 3 number of times, it can repeat 4 number of times, 100 number of times. Only one unique digit is present in an array, okay? So you have an array, length is n. Only one thing is unique. Suppose 7 is unique and everything else has occurred, like 2 has occurred twice, 3 has occurred thrice. It can go on like this, okay? 3 has occurred 3 times and so on. So what is your approach? How can you figure out 7 from this array? Anyone? It's just based on math. You need not know any data structure for this. Just how can we figure out 7 from this array? It's better if you say, because this chat box, okay, map. You say map. So how can you do it with map? Okay, means map means you are trying to say that I'll take the frequency and whose frequency is just once, then I can say that it is the unique number. But that will take space complexity linear, right? All the elements you have to store. Or not linear, because keys will be lesser than the size of the array, but still it's a linear linear space complexity. And also to go through it, you will require time complexity, yes. So space is a factor, otherwise it's fine. Yes, XOR of all elements, that is quite better. And why will it work? Why do you think that, Ujala Kumar? Can you say it?
Yeah, because XOR of similar element is 0.
Yes.
That means
So,
X XOR X is 0.
okay, so you say that if we keep on XORing everything, all the same things will get cancelled out, right? All the repeating things will get cancelled out. Yes.
Yes.
So that is a very good application of XOR. Well done. So what will happen? Just see this example. If I do XOR of every element, so this is suppose array of 0. Okay, this is the 0th index 1. It goes on like this. And if I keep on XORing everything, I'll run just a for loop. It will take linear time, but no extra space. So 3 XOR 3 will give me 0. and zeros or 2. So zeros or anything gives me that thing. Okay, zeros or anything, zeros or x will give me that thing. It will not change it. Okay, so because zeros or 1 is what is zeros or 1? So 0 changes, so it remains 1, and zeros or 0 is also 0. So whatever you do XOR with, it remains the same thing if it is 0. Okay, so zeros or 2 will keep your answer as 2. So answer starts with 0, and I run a for loop. Let me show you the code. So here what I have done is, there yes, there is a for loop. It takes values from this vector. The vector can be anything. User can give the vector. So I have taken the vector. This is the vector I have taken. This is the size of the vector. You can see here the expected output is 1. Why? Because 1 is the unique element. Other things are repeating. So if I run it through this, if I run it throughout the array, and I'm taking answer XOR equal to 1. So this is a shorthand notation of writing the same thing as, I can write, instead of writing this, what I can do is answer is equal to answer XOR. Okay, answer is equals to answer XOR I. The same thing. This is a shorthand notation. So every time I am XORing the elements with answer, and finally all the repeating things will be cancelled out, and we will be left out with 7. So in this case it was 1, not 7. So we have got the answer 1. Let me run it. So when we run it, 1 will be the answer. It takes a bit of time. Yes, so it will give me 1. So that was a good application of XOR whenever there is a repeating ones, but it will work for only one repeating element. Okay, if there's an interesting question, you can take it as a homework, or after this session we can discuss on Discord that the same question, but only 2 distinct elements are present, not 1. Okay, there are 2 distinct elements present, and everything else has duplicates. So can you find it out using the same logic? There will be a slight deviation from it. Okay, okay, understood. So there is a slight deviation from it, but try to maintain that. Okay, try to solve it. The same question, just 2 distinct things will be present. Okay, now we proceed to the question. So it's already 42 minutes, and it's the correct time to go to that. Okay, so how many of you have any doubt up to this? Because now we are going to solve a cook-off problem, and I think that will be enough because we don't have much time left. So any question till now? Anyone? No, I think.
No,
So let it.
no question, you can go ahead.
Okay. So let us start with that problem. Yes. So this question, I think I've given the link, or Girish have shared it on the chat box. You can see it, or will I open it? So I think just search for XOR problems, Codechef, and I think it was this one. So it came in this July, and it is a nice problem. Many of you have requested to solve problems from here. So suppose this is a problem. It says that given an array A of n non-negative integers, you can choose any non-negative integer x. Okay, it can be non-negative, means it can start from 0, and replace every element ai with the XOR of x. So basically we can do array 0 dot XOR x, array of 1 XOR x, array of 2 XOR x, like this, all the elements XOR x. So here this denotes the bitwise XOR operation. Okay, so using the above, okay, so this is, you can say, when you are working with digital gates, this is the symbol you see, but while coding you will use that caret symbol, not this one. So using the above operation exactly once, your goal is to minimize the bitwise OR of the new array. So it might seem the English is complicated, but this is what you have to do. This is this line is what you have to do. A1 XOR x and add them, just means OR them, or with A2 XOR x, A3 XOR x, like this, AN XOR x, all the elements XOR x, and you're ORing them. Okay, you have to minimize this expression. So whatever you get in doing this, whatever you get, you have to minimize this. Okay, so suppose, let me take an example. I take x is 5. If I take the x5, I'll get a value of this expression, like A1 XOR 5, A2 XOR 5, like this, AN XOR 5. Now whatever I get as a result of this entire expression, is it minimum? No. Another person says that if I take x2, then I get lesser than you, so he will win. So you have to find out a proper value of x that will minimize this entire expression. So is the question clear to you? It's a small question, 1 paragraph. Is it clear, or any doubt regarding the question?
Maya,
This
what do you
bit.
mean by minimize? Can you tell me that?
Minimize means suppose you take a value of x, suppose 10, okay, and I take a value 7. So you will, what you will do, you will do a1 XOR 10, a2 XOR 10, like this. You will do every element XOR 10, and you will apply this OR operations. Okay, so what you will get is an answer, and what I will get is another answer. If my answer is lesser than you, then I will win, right? So there is a one answer which is lesser than everyone. That is the minimal answer. So you have to minimize this result, choosing a proper value of x. X can be anything, but your task is to choose a proper value of x, which will minimize this entire thing.
Okay, got it. Thank you.
Got it, right? So the answer, I think the output format, it says that for each test case, we have to print two integers, which is x, that is the optimal value, which we have to figure out, and the minimum possible bitwise OR. Suppose after doing this thing, you get the answer as 3. You cannot minimize it further than 3. 3 is the ultimate minimum. Okay, the global minimum is 3. So you have to print out, suppose x was 7, so 7 space 3. That is how you should print. Like he has printed 4 space 6. So 4 was the x value and 6 was the minimum value. That is the out. So this is, sorry, this is input. This is the output format, 6 space 2. Okay, so that is how he have taken x6 and he has got the minimal value 2. This is the output format. And do we have any hint how to solve this? Any property of XOR? One thing they have mentioned that we have to use XOR. Okay, so any idea? How can we get a hint of minimum? We can do OR of all the numbers to get x. Okay, so how is this coming? Is how we can approach this? He has said the right thing, might have solved this problem as well. So other than that, what does XOR do? Okay, without wasting time, what does XOR do? XOR, if I take very close numbers which are very similar bitwise, then XOR will give me minimum, right? What is the logic of XOR? If you give me different, I will give you 1. If you give me similar things, I will give you 0. Right? 0, 0 will give you 0. 1 XOR 1 gives you 0. But whenever you give different bits, XOR will give you 1. So that is the core logic of XOR. So if I can figure out a particular x which is having common bits with most of the array elements, then I can get a minimum result. Right? Can you understand this line, that my aim will be to choose a particular x such that if I do XOR of x with every element, I can get minimum value because x is similar to all of them bitwise. I have to find an x which is very close to them, not very different from them. Otherwise, XOR will be greater. Okay, so I have to figure out something which is bitwise similar. Now, the logic is, let me go to the whiteboard. So suppose I consider very simple examples, then I go to a multi-bit example. So first I take single bits. A1, this is the array A1, A2, A3. Okay, just 3 elements I have, A1, A2, A3. It takes time, A3, yes, A1, A2, A3. Okay, now this, sorry, A2, A3, yes. Now I have to XOR it with a particular value of x. Now what value of x I can choose? That depends. Suppose A1 is 1, everything is 1. Suppose this is an extreme case. This is I am just evaluating the extreme cases. So all are 1. This is case 1. Okay, everything is 1. So when everything is 1, if I take x as 1, that is my aim, right? If I take x1, I can reduce the result. So what is my result? My result will be A1 XOR x, or as they have shown. Otherwise, I can also write like this. But let me show it like this: A1 XOR x. Whatever I get, okay, A2 XOR x, A2 XOR x, and same thing A3 XOR x. I'm not writing. Okay, let me write again. A3 XOR x. So these 3 results, whatever I get, I will do OR operation between them. So I will do this thing between them. So this thing or this thing or this thing. That is my final answer. Now, what do you think if I take x1? Then I get 1 XOR 1, which is 0, This will also give me 0, and since everything is same, so 1 XOR 1 will also give me 0. Now 0 or 0 or 0 will give me 0. Okay, at least one you need. At least there should be 1 present to get the result 1, but everything is 0, so our output is 0, and that is the minimal possible answer. Okay, this is the minimal possible answer. So we take x1 whenever all the bits are 1. Okay, whenever all the bits are 1, we take x1. Remember this. Now case 2, In case 2, suppose everything is 0. A1, the element is 0. A2 is also 0. A3 is also 0. I will quicken up a bit. A3 is also 0. Now, if I take x as 0, it will be beneficial. Okay, I want to match it with all the possible elements. Now, again, if I do the same operation that I've done here, that is, wait a second, go to this page. Yes. So A1 XOR x, now all of them are 0. So 0 XOR 0, okay, like 0 XOR 0. And this will be done 3 times, and then we will add them up or them up. Okay, this or 0 XOR 0, it goes on like this. Still we get 0, right? Because this entire thing is 0. This entire thing is 0. And another time we have this thing, same thing. Another time we do same thing. And so we get 0 or 0, 0, so answer is 0. So whenever every bit is 0, we are getting all the bits 0 in a particular case, we will consider x 0. That is the second conclusion that we can derive just by inspection. Okay. And the third case is the most common one, where we will get mixture. Okay. Mixture means suppose A1 gets 1, A2 gets 0, and A3 gets 1. Okay. A3 gets 1. Okay. Up to this, okay, I'll tell that at the end. After doing this, I'll see what you are asking. So 101, if this is the case, I'm taking only 1 bit numbers first of all. Then what will be the possible value of x? What will be the best choice for x? I can either take 0. If I take 0, what happens? 1 XOR 0, right? 0 XOR 0. 1 XOR 1. Hey, 1 XOR 0, right? Because x is fixed. X is fixed every time, right? So you get this is 1, this is 0, this is 1. So 1 or 0 or 1. What is the result? 1 or 0 or 1? It is 1. So you're getting 1. Can you reduce this answer? Can you reduce this answer by taking x 1? I don't think so. Why? Because when you do 1 XOR 1, you will get 0, fine. But when you get this, 1 XOR 0 will give you 1. So you will basically get 0 or 1 or 0. So 1 remains, at least 1 will remain. So you cannot avoid 1. 1 is the minimum thing possible. So whenever there is a mixture, you can take any values. You can take 0, you can take 1, it does not matter. So these are the 3 rules that we have got. If everything is 1, you take x1. If everything is 0, if everything where it went, okay, if everything is 0, we take x0. And if there is a mixture 1 0 1 0, then we can take any values, either 0 or 1, it does not matter. You are going to end up in getting a minimum. Now coming to the complex case, a real life case. Okay, give me an example. Suppose I take 1, or suppose I take 3 9 and 11. Okay, 3 9 and 11, suppose. Now let me write it down. 11 is 1 0 1 1, 9 is 1 0 0 1, 3 is 0 0 1 1. Now these are the 3 elements of an array. Okay, this is A0, this is A1, this is A2. This is now I'm dealing with a real type example. Okay, 3 9 and 11 can be the array elements, and this is the binary forms. So what is my x? My x will follow the rules that I've discussed. Okay, stick to any one rule. Okay, either you choose 0 for mixture, or you choose 1 for mixtures. Okay, I will choose 0 for whenever I get a mixture. So there everything is 1. Okay, this row, just focus on this column. Everything is 1. So what will be my preferred x at this position of the bit? What will be my x? I'll take it 1. I want to make it as similar as possible. Okay, then I come to this column and I see that there is a mixture 1 0 1. So I prefer 0. For any mixture I prefer 0. Here there is a purity of 0. Everything is 0. There is no 1. Okay, so I take 0. I take 0 for this position. And finally there is also a mixture here 1 1 0. There is a mixture. So for mixture I prefer 0. You can also take 1 for mixtures, anything. So by following the 3 rules in the previous page, we have made this x. So if our array given in our question is this, then we can safely take a possible value of x like this. Okay, and you can try and test it out. You do A0 XOR x or A1 XOR x. If you do like this, you will get a minimum value. Okay, so that is the logic to solve this problem. Is there any doubt right now? let me see the chat box, that how we are approaching to solve this question. Anyone? We can do OR of all numbers to get x. Yes, that is what we will come right now. So basically, what have we done here right now? What is this logic? So whenever we get everything as 1, our output is 1. Whenever we get everything is 0, our output is 0. Whenever we get a mixture of 1 and zeros, what we write? Here we have taken 0, you can also take 1. So the person who has answered that we have to do OR of all the elements, here followed this rule, 1, 0, 1. So this is, what is this rule? This is the rule of AND. Just look carefully, this is the rule of logical AND, or you can say the Boolean algebra AND operation. See, everything is 1, we take 1. Everything is 0, it is obviously 0. And if there is a mixture 1 and 0, we get 0. That is the AND logic. That I am following. And he said that we have to do OR of everything. Why he said that? Because he was following this rule. That is, whenever you get a mixture, you take 1. You can take anything. He took 1. Whenever you get everything 0, it gives you 0. Whenever you get all the things 1, it is obviously 1. So that is the rule for logical OR. That is the rule for logical OR. You get a mixture, it is 1. You get zeros, it is 0. You get 1, it is 1. So basically, we have to do AND of all the things or OR of all the things, whatever you prefer. I am doing here AND. Okay, I am doing here AND. I'll do AND of A0, A1, A2, everything I'll do AND. And then I'll get X. That is what I've done here. I have taken AND, bitwise AND of all the array elements. So let me take you to the problem. So if I take you to the problem, so here what I have done, this is just for running the test cases, nothing else. So this is the length of the vector or array, whatever, of size n. So there are n elements in the array, and for every element we have taken input, that is fine. Now, okay, why is this so? Because before taking AND operation, it is safer to initialize x something like this. Okay, before we do AND, this is simple. Suppose we do AND with something like this, it will not affect, right? If we take something minimum, what we do? We initialize it with int max. We take a maximum value, right? We take a maximum possible value whenever we are storing value for a minimum variable, right? Similarly, if you want to do AND with something, it is safer to take it as 1, because 1 and something is that thing. 1 and x is x. So whenever you're doing AND with something unknown, better take it as 1. So I have taken every bit of x as 1 initially. I have initialized x like this. So what is this? This is the 2's complement of -1. Just not to confuse, you can also take like this. You take x as array of 0. The first element you take x, and then you do x and a1, x and a2. Okay, you keep on doing like this. Okay, that is also possible. I have taken the initial value of x as something like this, because you do AND with this thing, you will get that thing. So it is safer to initialize something like this whenever you're going to take AND. If you're taking OR, then take everything 0. Okay, take everything 0. So here I've taken everything 1, so it looks something like 1, 1, 1, 1, 1 in 5 bits. Now I have taken AND with every element of the vector. It is very clear. Y is any element of the vector, I'm taken AND with it. So now I have got my x. This is my optimal x. So the moment I reach here, I have got my optimal x. Now just I need to follow the question. What does the question say? The question says that, let me go to the question. It says that we have to do A1 XOR x, A2 XOR x, A3 XOR x, like this, AN XOR x, and then we have to do OR with it. Okay, so that is what I've done. I blindly follow the question, that do OR operation. This is answer. Let me write it simpler terms. Answer is equals to answer or this thing, x or y. What is x? X is my optimal value, which I have found out, and y is any array element. So y will take array 0, array 1, array 2. Okay, I have done XOR, and then I have done OR. This is just the implementation of the question. So the actual fun part was doing this, how to figure out that by doing repeated AND operation, I can get an optimal x. So the core logic was that XOR finds similarity. So if you want to make things as similar as possible, you devise some rules for it. So I have devised that, okay, if I get 1, I will keep it 1 because it is similar. If I get 0, I will get it 0. And if I get mixture, I will keep it mixture, 0 or 1. That was my rule. And following that rule, I have made a logic. Like I have made an AND logic, and he has got an OR logic. So following that logic, I have made this, got an optimal value of x. Once you get this thing, your problem is solved. Now just this is the interpretation of the question. And finally, we are printing out the optimal values, giving a space, and finally the answer. Just check it out. So if we just run it, okay. Okay, where was the question? I think here was the question. Wait a second. Yes, the sample input was 1, 1, 4, and 6, and we got sample output as 6 and 2. Okay, so 1, 1, 2, 4, and 6. Okay, 1, 2, 4, and 6, right? 1, 2, 4, and 6. That was the input, and expected was 6 space 2. Let me see whether it's running properly. So okay, so you don't think that it is wrong because it says that there are multiple answers. You can give any one answer in case of multiple answers. Okay, so
Why you took 2 ones in the beginning?
yes, I think this was the number of test cases. Wait a second. Okay, yes, test. Sorry, this one is meaningless. This one is meaningless. Now I think still it will give me error. Why? You know, because this is a different answer. This is a different answer. 4, 2 is a different answer. 6, 2 is a different answer. Both will work. Both will work. Okay, if you submit it, if I just take this entire thing, Control C, if I go here and if I go to submit it, suppose I choose any account and log in, and then I just submit it, it will be submitted. Do you want to see it? Let me go here, submit, and not Python, C++, paste it, and just not custom input, submit it. So do you have any doubt? Then we can discuss regarding this problem. It is a good problem based on bitwise operation, especially XOR. It is taking time, just wait for some time. Oof, it seems very nice to see this thing, right? So it is successfully submitted, and now any one of your doubts to how this is happening, let me go to Zoom. Where is that thing? Yes, I think anyone have any doubt? You can speak out, right? So I think the session is almost complete, but this bitwise OR is never complete. There are many other things I'll tell you, like I'll tell you to toggle kth bit. K can be 8, 9, 10, user will give it. So can you do that? Like you want to toggle the 7th bit, or you want to toggle the 9th bit. If it is 0, you make it 1. If it is 1, you make it 0. So that is an interesting problem. We can check it out. So many things are there we cannot cover within 1 hour, but the main things we have told you, all the variants possible. Any other whatever you want to ask, you can please unmute. So the question session is open, or already 1 hour is over. So anyone? Or how many of you have attended the July cook-off? Are you seeing this question for the first time?
Yes, first time.
First time, no? Then it is better for me, right? Because if you have already seen it, then it's spoiling the thing, right?
Yeah.
So was it a good question?
Yeah,
I think standard question, not very difficult, but still it's okay. So there are many options. You just search, like I have done the XOR problems, code forces or Codechef. You will get many XOR problems like tagged. More or less, the basic is you break anything into the bits, and then you try to find the pattern. Sometimes it will be XOR. Most of the time it is XOR. That's why it's very important. Otherwise, you can also find AND and OR things. So in our Discord channel, what we will do is in the next week, we will have a contest based on these bitwise operators. And please participate in that, because we'll keep a session on the doubt clearance, all the problems starting from first to end. So after that, whenever you participate in lunchtime or cook-off, or even in code forces contest, you will whenever you see something based on bitwise things, you will solve it very quickly, right? So so our target is to target the topics one by one. So first topic was bitwise, and gradually we'll cover the other topics as well. So please don't miss the contest, keep them. Especially if there is some bitwise problems, please attempt them from now. So Girish, anything else?
No, I think that was a fantastic session from you. And do we have any more doubts in the chat, or anyone, if anyone has any doubt? Okay, Shubhadeep, you can stop sharing your screen.
Okay.
Okay, so yes, you will be getting the recording of the session, and the code and the PDF will also be available to you. The recording will be posted on YouTube soon after the session gets over. And there's one more announcement that I want to make. So just after the session on 16th, we have this mashup contest on code forces, which should be of 2 hours. You will be getting 5 problems to solve it. And Shubha, I guess you can share the code forces group in the chat so that people can join in.
Yes, Girish, I've done that.
Yes, so using this link, you can join this Code Forces group. So we have this Code Forces group for our club where we will be organizing mashup contests. We have previously also organized some contests, and there is an upcoming contest on 16th, that is Friday, that will be beginner around 4, and the questions here will be mostly be related to bit manipulation, the topic that we had discussed today. And following up this contest, there will be a post contest discussion on Saturday, I guess, Shubha. So either on Saturday or Sunday, we'll be having a post contest discussion for these problems. So you can join our Code Forces group there, and you can also follow our Instagram page. You can follow our other social media handles like LinkedIn, Facebook, to stay tuned to our announcements. And I think Shubha can also share the Discord link. So this is our Discord channel, and here you can, just like collaborate with any other people. You can ask your doubts. You can interact with other people, and you have a lot of people here whom with you can chat. You can post your questions here. So this is a community that we are building. We aim to provide you with a peer programming environment so that everyone can learn and grow together. So I guess that was it. That was it from our side. And if you have any questions, yes. So many people are asking about the certificates. So people who will be attempting the contest on 16th of this month, they will be getting the certificates. The certificate for participation will be provided to all the people who participate in this contest. And I guess I've answered all the doubts that I had received. If you have any more doubts, you can just post it in the chat. Rishikesh, you have to make an account and then you can join this group on Code Forces. Okay, then I guess that was it. Thank you for joining. Thank you for taking out time to join this session. I hope you guys found it interesting. There's a feedback form in the chat box which you can fill it up. Your feedback is very valuable to us and helps us to evaluate ourselves. So thank you guys. Thank you very much. Thank you for joining this session. You may leave now.